Welcome, friends. As an expert exploratory coding strategist and mentor, I understand that the journey of selecting and experimenting with a new programming language is far more than a technical decision. It's a strategic investment in your long-term growth as a practitioner. My aim is not to provide a fleeting recommendation, but to equip you with a robust framework for making such decisions throughout your career. 1. Deconstruct the core principles. Any successful approach to choosing your next programming language rests on a few non-negotiable, timeless principles. Align with deep learning objectives. Not just surface-level hype. The why behind learning a new language is paramount. Are you seeking to grasp a new programming paradigm? Example, functional, declarative. To tackle a specific domain problem? Example, embedded systems, high-performance computing, distributed systems? To enhance your understanding of computer architecture? Or to address a perceived gap in your existing skill set. Without a clear underlying learning objective that goes beyond mere popularity or job market trends, your exploration risks becoming directionless and ultimately unfulfilling. This principle is non-negotiable because true growth comes from intentional learning, not from chasing fleeting trends. Embrace cognitive overhead as a strategic investment. Learning a new language involves more than just syntax. It encompasses its unique ecosystem, tooling, libraries, community idioms, and underlying philosophical assumptions. This initial cognitive overhead is not a cost to be minimized, but a strategic investment in expanding your mental models and problem-solving repertoire. Acknowledge that the discomfort is a sign of genuine learning, and that this investment will yield dividends in terms of adaptability and a deeper understanding of computer science fundamentals. Seek leverage points for paradigm shift. Choose a language that offers a significant conceptual departure or a unique leverage point that will force you to think differently. If you primarily work with object-oriented, imperative languages, exploring a pure functional language or a language with a strong type system can profoundly expand your perspective. Learning another language that is merely a syntactic variation of what you already know offers diminishing returns for exploratory learning. This principle is vital for fostering intellectual agility and avoiding a plateau in your development. Prioritize practical application over theoretical accumulation. A programming language is a tool for building. While theoretical understanding is crucial, the true mastery of a language comes from doing. Actively building small, meaningful projects in the new language will solidify your understanding, expose practical challenges, and accelerate your learning far more effectively than passively consuming documentation or tutorials. This hands-on engagement ensures that knowledge is integrated into skill. Cultivate a growth mindset towards frustration. The learning curve for any truly new language will involve moments of significant frustration. Errors will be cryptic, idioms will feel unnatural, and progress may seem slow. Approaching these challenges with a growth mindset, seeing frustration as a signal that you are pushing your boundaries and expanding your capabilities, is essential for perseverance. Without this resilience, the initial hurdles can quickly derail your exploratory efforts. 2. Diagnose the central tension or paradox. The most common and difficult to resolve tension at the heart of choosing the next programming language is The paradox of immediate utility versus foundational expansion. On one side, there's the compelling pull of immediate utility, selecting a language that directly addresses a current project need, aligns with a popular job market demand, or offers a quick path to building something tangible. This approach feels practical, efficient, and often provides a clear short-term return on investment. It's about solving a present problem or advancing a specific career goal. Choosing a language for a specific task, such as Python for data science or JavaScript for web development, offers clear, goal-oriented efficiency. On the other side is the equally important drive for foundational expansion, opting for a language that deliberately introduces you to new paradigms, challenges your existing mental models, or deepens your understanding of core computer science principles, even if its immediate practical application isn't obvious. This approach is about long-term growth, versatility, and becoming a more adaptable and principled engineer. Languages like Haskell for functional programming or Rust for systems programming with strong memory safety fall into this category. Why this tension is so challenging? The challenge lies in balancing the desire for tangible, measurable progress, utility, with the need for deeper, often less immediately quantifiable intellectual growth, expansion. Focusing too heavily on immediate utility can lead to learning another flavor of what you already know, missing opportunities for genuine conceptual breakthroughs. Conversely, focusing solely on foundational expansion without a clear application can lead to theoretical learning that lacks practical reinforcement, resulting in knowledge that fades without use. The fear is either stagnating in your current skill set or getting lost in academic abstraction without gaining practical, transferable skills. The most effective path often involves finding languages that offer a blend, providing enough utility to sustain engagement while simultaneously pushing you into new conceptual territory. 3. Generate a tiered strategy framework. To navigate this challenge effectively, a tiered strategy framework is essential. Foundational layer, the bedrock. Before you even consider which language, establish these fundamental habits and mindsets. Clarify your learning thesis, the why. Dedicate time to articulate why you are exploring a new language. Is it to understand concurrency better? To explore functional programming? To build a specific type of application? Example, game, web API, embedded system, to improve performance. This clarity guides all subsequent decisions. Resources often emphasize defining goals before choosing a language. Audit your current conceptual gaps. Honestly assess your existing programming knowledge. Where do you feel conceptually weakest? Are you comfortable with dynamic typing but want to wrestle with static typing? Are you strong in imperative programming but curious about functional paradigms? This self-assessment helps identify leverage points for growth. Languages that offer a significant conceptual departure, such as functional, object-oriented, or memory-managed languages, can help developers gain a better grasp of software engineering. Allocate a realistic time and energy budget. Learning a new language is a significant undertaking. Be realistic about how much focused time you can consistently dedicate. A consistent, smaller effort, example, 30 minutes daily, is often more effective than sporadic, intense bursts. Practical layer, the engine. Once the foundation is set, these actionable strategies will drive consistent progress. The micro-project iteration. Instead of aiming for a large application, start with a series of tiny, self-contained projects. Examples include a command line utility. Examples: a file parser, a simple calculator. A basic web API endpoint, if applicable. A simple data transformation script. A classic algorithm implementation. Examples: sorting, searching. These micro-projects provide immediate application, allowing you to quickly encounter core language features and idioms. This approach is supported by advice to write code, solve problems, and build projects. Deep dive into core constructs first. Resist the urge to jump immediately to frameworks or advanced libraries. Master the language's fundamental syntax, data types, control flow, functions, and basic data structures. Utilize the official documentation and interactive environments, REPLs, for rapid experimentation and understanding. Engage with the community. Join online forums, Discord servers, or local meetups for the chosen language. Observing how others solve problems, asking questions, and even answering beginner questions can accelerate your learning and expose you to idiomatic practices. Read the masters, code reading. Once you have a basic grasp, actively read well-written open-source code in the new language. This practice is invaluable for understanding best practices, common patterns, and how the language is used effectively in real-world scenarios. Advanced layer, the mastery. To transition from competence to true mastery, integrate these sophisticated techniques. Explore the ecosystem's depths. Once comfortable with the language, delve into its prominent libraries, frameworks, build systems, testing tools, and deployment workflows. Understand the why behind their design choices. Benchmark and understand performance characteristics. For languages where performance is a factor, understand its memory model, concurrency primitives, and runtime characteristics. When is it exceptionally fast? What are its common bottlenecks? This fosters a nuanced understanding of its strengths and weaknesses. Contribute to open source. Even minor contributions, example documentation improvements, bug fixes, to an open-source project in the language will force you to interact with an existing codebase, adhere to community standards, and collaborate with experienced practitioners. Undertake a non-trivial, self-directed project. Build something genuinely challenging that requires integrating multiple aspects of the language and its ecosystem. This project should push your boundaries and expose you to complex design decisions. Teach or mentor others. The act of explaining complex concepts to another person is one of the most powerful ways to solidify your own understanding and expose any gaps in your knowledge. 4. Curate a resource matrix. Here's a curated list of resources to aid your journey, categorized to support different aspects of your learning. Foundational text. The Pragmatic Programmer: Your Journey to Mastery by David Thomas and Andrew Hunt. This book is a timeless classic that emphasizes fundamental principles, best practices, and the craft of software engineering. It focuses on language-agnostic concepts like debugging, testing, automation, and communication, providing a holistic view of becoming an effective developer. It's celebrated for its enduring relevance and ability to shape a modern developer's attitude towards design and critical thinking. Practical Guide. Crafting Interpreters by Bob Nystrom. This excellent, freely available online book guides you through building your own programming language from scratch. It's a highly practical and engaging resource that demystifies how programming languages work, offering profound insights that are applicable regardless of the language you ultimately choose to specialize in. It's well organized and provides a project-based approach to understanding languages and compilers. The official documentation of your chosen language. For immediate, actionable steps, the official documentation, tutorials, and getting started guides for your chosen language are often the most accurate and up-to-date resources. Cognitive Catalyst. Designing Data-Intensive Applications by Martin Kleppmann. This book is a practitioner-oriented guide that delves into the principles of building robust, scalable, and maintainable data systems. It challenges conventional thinking by exploring the trade-offs and underlying mechanisms of various data technologies, fostering a deeper understanding of system design that transcends any single programming language. Reading it will give you a lot of important context on how actual software design works, especially if you've primarily focused on theoretical computer science. 5. Final synthesis and forward-looking question. The essence of choosing your next programming language lies not in finding the perfect tool, but in cultivating a strategic mindset that prioritizes intentional growth over passive acquisition. It's about viewing each new language as an opportunity to expand your conceptual toolkit, challenge your assumptions, and deepen your understanding of the craft itself. The true measure of your success won't be the number of languages you know, but the depth of understanding and the intellectual agility you gain from each deliberate exploration. Therefore, my central piece of advice is this. Choose your next language not for what it does, but for what it teaches you about the fundamental nature of computation and problem solving. And to encourage your own continued reflection, I pose this provocative question. Beyond syntax and libraries, what fundamental truth about software engineering are you truly committed to uncovering with your next language experiment? That's all, friends.